How's it going? This is Mr. Hernandez, and I want to go over this first example of a recursive function. So what you want to do first is, in order to come up with the outputs, we gotta basically use this to determine the inputs. And here it's saying we're gonna start at 1. And so we're going to basically make a sequence that starts at 1, then goes to 2, then goes to 3, and so on. So I'm going to go ahead and recopy this here. And what we're going to do now is plug in 1 into it and see what we get. So it's going to be 3 times 1 minus 4, which is equal to 3 minus 4, which is equal to negative 1. So all this gets carried down. So f of 1 equals negative 1. So that means the first term here, this is the term number, and this one's a negative 1, the term value. So the first term needs to be negative 1. So this is negative 1, and this is negative 1. This one is not, and this one is not negative 1. Okay, so we have two choices here, A and D. All right, let's look at what the value would be for 2. So I'm going to go ahead and do that maybe over here. So f of 2, so this is n, right? So f of 2 equals 3 times, well, it's 3 times n, so that's 3 times 2 minus 4. And then 3 times 2 is 6 minus 4, and then 6 minus 4 is 2. So f of 2 equals 2. So this is the second term, and this is the second term's value. So the second term is going to be 2, so this one cannot be right. So it's got to be A. All right. Now, so once we, and so here I could just say, my thinking was, I plugged in 1 and 2 into the function to determine the first two values. Okay, next, so this is the real tricky part. So here you're basically trying to come up with the recursive formula based on this pattern. And so remember, it was negative 1, and then it was 2, and then I believe it was 5 after that. And you could check, the previous slide, but I believe that's what it was. So so we got to ask ourselves which one is going to give us the answer. And so we're looking to get, instead of plugging in 1, 2, and 3 here, what we need to think about is whatever value we get here, what's going to get us the next value. So for example, if we use this one, well first, there's not going to be, on the left side, it's just going to be a function. There's not going to be anything crazy like this, so we could cross this out. So these are all just, functions. So let's look at this one here. So this is saying, let's say the first term, okay? Actually, we got to use, let's do first term. So this would be f of, and then again, I'm plugging into here, that's the term number, 1, minus 1 plus 3, and that's going to be f of 0 plus 3. Well, we don't know the 0 term, right? There's only the first term. This is term number 1. We don't know term number 0. So plugging in a 1 won't help us, okay? So instead, let's plug in a 2. So if we plug in a 2, so this is going to be 2 minus 1. This would be f of 1 plus 3. So what is f of 1? Well, the first term is going to be negative 1. That's f of 1, right? F of 1 equals negative 1. So if I replace this with negative 1, and then I bring down the plus 3, I'm going to get negative 1 plus 3 is 2. So imagine that. I plug in, right here, you see that I plugged in 2 because I want to know what I get when I get the second term. So if I plug in 2 for the second term, I'm basically being told, okay, well, you're going to take this first term, negative 1, and you're going to add 3. And so here you get a 2, which is correct. That's it. So this has got to be the answer. Let's see what we get here with this one. So I'm going to say, I'm going to also plug in, the second term. So I'm going to say f of 2 equals 3 times f of, instead of n minus 1, I want to plug in 2 minus 1. So this is going to be f of 2 equals 3 times f of, well, 2 minus 1. 2 minus 1 is 1. Okay, so we're plugging that in. Now, what is f of 1? Again, f of 1 is over here, which is negative 1. So we're going to plug in negative 1 here. But notice this 3 is multiplying here. So we're going to bring down that 3 and multiply it to negative 1. And 3 times negative 1 is negative 3. So I'm just going to bring these equal sign down, f of 2 down. So this is saying the second term, the second term has a value of negative 3. Well, actually, that's not true, right? Because we see that the second term should have a value of 2. So it cannot be negative 3. So this is wrong, okay? And then let's do the last one. So I'm going to look for the second term again, and we're looking to get a second term output of 2, right? So let's plug this in here, and our second term here. Okay, so this is going to be 3 to the power of, well, 2 minus 1 is 1, and then 3 to the 1 is still 3. So this is saying f of 2 equals 3. So is our second term, is that value going to be 3? Well, let's look here. This is our second term here. And no, it should have a value of 2. So we know that this is wrong. So this must be the recursive formula that corresponds to this formula, which is called explicit. Okay, so this is the explicit form right here. And this one down here is the, well, let me put this in red. So explicit form is this one, okay, that's what that one's called. And the recursive formula is going to be this one here in option B.